Okay, everybody, let's recap the lesson. So I'm on page 510, and we're talking about square root graphs that are inverses of parabolas. So we started with x squared minus 4, and all that is a translation down 4. Okay, so then when we went and solved for the inverse, when we switched x and y, we ended up going, y equals x squared minus 4, but then if we change to x equals y squared minus 4, and we solved, we wound up getting a plus or minus the square root of x minus 4, okay, f inverse, right? And then when we looked at graphing that, if you do the plus or minus, you get the full curve here, okay? Well, the problem is that is not a function, okay? So what we're going to do is a domain change. We're going to restrict the domain today. So what we're going to do then is we're going to get rid of this bottom half by getting rid of this part of the graph here. So if we get rid of this back half of the blue graph, we get rid of the bottom half of the red graph. So what we're going to do is we look at restricting the domain. So what I did is I restricted the domain. Let's have x be greater than or equal to 0 only. Okay, so then we redid the graph. Okay, so then what we did is we used a little bit of whiteout. We took away the back half of the graph because we restricted the domain. And then if we do that, then you get rid of the bottom half of the square root graph. Okay, and then instead of it being plus or minus, the equation is really now going to be y equals just the square root of x minus 4, okay? A couple of things we noticed is now the domain becomes the range, and the range becomes the domain of the inverse and its function, okay? And we also noticed the x-intercepts become the y-intercepts, and the x-intercepts become the y-intercepts, okay? So we switched all the points. Then we also looked at the cube root graphs. Cube graphs are pretty similar. We graph the x cubed. Then we reverse the points, and we graph the cube root. So we have is a y equals the cube root of x. What I notice is it is definitely a function, so I don't need to worry about restricting the domain range. I can just leave the domain range as all real numbers, and the range is all real numbers. So I know that the domain and range of both is all real numbers, and the range of both is also all real numbers. Okay, you can just see it goes forever this way, goes forever up and down for both graphs. Okay, then we talked about graphing square roots. Okay, so I did a little bit of notes, took a look at the parent function, the square root graph, and when I graph square root graphs, I like to use these numbers. I like to plug in 0, plug in 1, plug in 4, plug in 9. Why these numbers? These have square roots. So the square root of 0 is 0. Square root of 1 is 1. Square root of 4, square root of 4 is 2. Square root of 9 is 3. All the other numbers are in here. I did not use any negatives because you can't take square roots of negative numbers. Okay, so then that is the parent function. That's the square root graph. Okay. Domain and range. Domain is x is greater than 0. Range is y is less than or equal to 0. Then we did some translations. We took the parent function, this graph here, and we took it down 3. Okay, so we did the exact same graph. We just translated it down 3. We still have the exact same points, but just down 3. It did not change the domain, but it did change the range, because the range now starts at -3 and goes up. Looked at another one. If I put a negative in front of this, what happens with a negative in front of it? It makes it upside down. You can see this graph's upside down. So I translated it up 2, and then I made it go upside down. So I still have the 1, the 4, and the 9, okay? Square root of 9. So then we did another one. Oh, domain, range, okay? Domain is greater than 0, but the range is less than, because you're going down less than or equal to 2, okay? Then we did another one. We graphed this one. We know we have a translation of over 2, down 3. It's always the opposite of the inside, so we went horizontally, went to the right 2, opposite. Remember, opposite of the inside, and down 3, and then I put the parent function. Now that does change the domain and range. Domain is x is greater than or equal to 2 because it starts at 2, and the range is y is greater than or equal to -3, okay? Then I did a third example. Third example is here. I know I'm going to go back 1 and up 3, and I put the parent function is. Now, what I did is in pencil, I put the parent function, and then I have applied the 2. So the red is actually the correct graph, because what I did, because of the 2, is I made every point twice as tall. Twice as tall, twice as tall. From instead of height of 3, it's a height of 6, so twice as tall, okay? The last thing I did is said, okay, here's an equation. Let's figure out here's a graph, let's figure out what this equation is. Well, I do know a couple of things. It's got to be a square root graph, I do see that. It's upside down, I know it's got to be negative. There's no horizontal movement, so it's just got to be an x, and it's been moved up a positive 2. Now there's one thing though, it's a little bit taller than a normal graph. In fact, I think it's twice as tall, because instead of 1, 1, it's 1, 2. So I'm going to rewrite this as y equals a negative 2 square roots of x plus 2. And that's the equation for that graph. Okay, that's what I had for the day. And then we had a worksheet to graph these and a mathia that's due today. Okay? That's all I have.